Our next two functions that we need to know are exponential functions and natural logarithmic functions. And these are mainly important when you get to calculus because they're very common. Your natural exponential function would be y equals e to the x. E being the natural base or the Euler number. And then your domain for that is negative infinity to infinity because x is in the exponent. It's not in a square root or a denominator. So that means you can plug in negatives and positives. So let's plug in, so let's plug in -2 to +2. And so you would get e to the -2nd, e to the -1st, e to the 0, e to the 1, e squared. Now, before I say that, let's go ahead and change these negatives. So if you have a negative exponent, that means it belongs in the denominator. So that would be 1 over e positive squared, and then 1 over e to the +1 for those two negative exponents. Now, e is approximately 2.7, and you can type that into your calculator to see the full decimal. It's an irrational number like pi, where the decimal just keeps going on forever. So we've got 2.7. Now, if we just approximate that as almost 3, then we can kind of get a rough idea of these points. So 1 over 3 squared would be approximately 1/9. 1 over e would be approximately 1/3. Anything to the 0 is 1. E to the 1, so that'd be 3 to the 1st is 3 approximately. And then 3 squared is approximately 9. So the graph then at -2, I'll need to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -2 is at 1/9. So that's really close to the x-axis. -1's at 1/3. So that's also really close to the x-axis. 0 is at 1. 0 is at 1. 1 is at 3. 1, 2, 3. And 2 is at 9. So it increases really fast, which is why it's called exponential. Well, it's called exponential because it has an exponent, but exponential functions increase really fast. So it's this rounded looking shape like that. Now, I think the easiest thing to remember is that it hovers above the x-axis. It goes through the y value 1, has a y-intercept of 1, and it curves up. It increases. All right, natural logarithm is the inverse of e to the x, so that's natural log x. And for that, so for natural logs, there is a restriction on the domain. So natural logs, the domain of this function would be 0 to infinity. It has to be positive. And actually, 0 does not work. So it's like parentheses around your 0. So for your x and your y, you cannot plug in 0. That's undefined. But you can plug in all positives. So like 1, 2, and 3. Now, those are hard to, or you actually can plug in, you can plug in fractions as well, but let's just stick with those. So those are hard to actually graph or figure out without a calculator. Now, if you have a calculator, it's easy. But natural log of 1 is 0. Natural log of 2, I couldn't tell you. Natural log of 3, couldn't tell you. But I know the graph. So that table isn't really helpful. Sorry. But the graph, we know it's going to cross 1, 0. And at 2, this is a positive number. This is a positive number. So it looks like that. And if you plug in actually like 1/2, you'll have natural log of 1/2, which is actually a negative number. And so it looks like this. Now, for natural log, I just stumbled my way through that table because I don't actually think about the table there because you have to have a calculator to do it. And what I know about E and natural log is that they're inverses of each other, which means you can just reflect over the line y equals x. So if you draw this diagonal line through 0, 0, and 1, 1, you are just reflecting your E graph over that line, and that creates the natural log graph. And so I don't actually know my natural log graph very well. I just know my E graph really well, and I just always think about if E looks like that, then I'm just going to reflect it, and that must be my natural log. So, for example, I know that E goes through a y value of 1, so natural log has to go through an x value of 1. That's just how I remember it. Okay, so those are your parent graphs. Now what we're going to do is we're going to change them. We're going to start by doing some vertical shifts. So, if you have your function, but you are adding a number to the side, then that means you are shifting it upward. That's going to go up. If you are subtracting a number off to the side, then you are going to be shifting your graph down. So this shift is up 2, and then this shift is down 4. So you can go right into your graph, or you can make a table, or you can make a parent graph and change your graph. Let's try 2 different methods here. On this first one, let's just start with a parent graph. We're going to start with the graph of E. Now we know the graph of E because we have it right there. So -2, okay. So we know -2 is about 1/9. We know -1's about 1/3. We know 0's at 1. We know 1 is about 3. And we know 2 is about 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, you didn't count that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm going to make a dotted curve for those. Now that's my parent graph, but we're going to shift each point up 2 units. So instead of 9, it'll be at 11. Instead of at 3, it'll be at 5. Instead of 1, it'll be at 3. Instead of at 1/3, well, if you add 2 to that, it'd be 2 1/3. Instead of 1/9, it'll be 2 1/9. And then I'm going to sketch the curve there. So then that means instead of curving towards 0, it's now curving towards y equals 2, because we shifted it up 2 units. So that is one way of how you could do your shift. Start with a dotted curve and then just move it. For shifting down, you can do the same thing I just did, or you could actually do a table if you like tables. So we know for absolute value that we plug in negatives and positives. And then what I would do then, if you want to use a table, is just focus on absolute value first. And then we will take the y values and we will subtract 4 from them. We'll shift them down 4. So we know the absolute value gives us 2, 1, 0, 1, 2. And then if you take 4 from them, it'd be -2, -3, -4, -3, and -2. And then you can just plot those. So it'd be -2, -2, -1, -3, 0 is -4, 1 is at -3, and 2 is at -2. So that was using a table instead of a dotted parent graph. And you can tell by the parent graph, which is right here in red, that we just moved every point down 4 units if you didn't want to use a table. All right, horizontal shifts. If you are subtracting c from the x, meaning inside the parentheses, then you are shifting it to the right, which seems counterintuitive. So it's always the opposite of what you think. So if it's subtracting, you're going to the right, and if it's adding, you're going to the left. If it's adding, you're moving to the left. Now, I gave you 2 examples that don't have parentheses because a denominator and a numerator act like parentheses, and a square root acts like parentheses. So if you have a number being added or subtracted in the denominator, then that is moving it left and right. If it's moving up and down, it'll be outside of the fraction off to the side. So this is telling me to move right 2 units. Let's just go with the parent graph method. So I'm going to start with just 1 over x. And we know that that would be, if I plug in -2, it'll be -1/2. If I plug in -1, it'll be -1. If I plug in +1, it'll be 1. And if I plug in +2, it'll be 1/2. This is the original graph. And then we're going to move everything right 2 units. So instead of -2, it'll be at 0 1/2. And then instead at -1, it'll be at 1. So 1, 2. Instead of 1, it'll be at 3. And instead of 2, it'll be at 4. Which means the asymptote, or the center of it, has actually moved to 2. And that would be a picture of your graph. Okay, +5, that means we're going to go left 5. And we'll do that parent graph again. Okay, so you're going to start with square root. Now we know that has 0, 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. And we're going to move all of those points left 5. So we're going to go 1, 2, 3, 4, 5 for the 0. And then the next one will be at 4. And then the next one, let's see, 1, 2, 3, 4, 5 will be at -1. And then the next one will be at 4. So that we just shifted each of these left 5 units. Which means it looks like that. Okay, and now we're going to talk about reflections and stretches. And we'll do that in the next video.